come on. There we are. So I have the pleasure of going through a lot of the cryptocurrency, blockchain, and other stuff. With my team does that, and we run into a lot of things on the way. And some of the things we do, I was thinking about showing you. The reason for that we see a lot of problems are this: there's a lot of money in this business. It's about, I don't know how I would say this, but $136 billion in DeFi today, which is quite a lot of money. So there's a lot of people trying to get hold of this. What we've done in the work is that we haven't sort of been able to do the thing that most psychologists do to find out who's the scammers. So who you can trust, that's up to you as a user or as a customer to these companies. So, no, there we are. A little bit quick for this. So, a lot of things that we've found. So, for example, we have rounding errors that unfortunately cancel themselves out because of the way that blockchains calculate time. So we had a problem with an interest rate that was 20% off, but based on the fact how they calculated time, it actually was 0. So when the blockchain actually started to pick up speed, the interest rate went off, and they couldn't figure out why until we looked at the code and suddenly realized, okay, this is why. So now they look at something else to have as a time reference instead. This is an interesting one. Programs that look and sort of check that it's actually itself. So 1 equals 1. Okay, so let's everybody do whatever they want, this program. That's not too good either. Then we have the ones that let everybody sort of change the parameters on the fly when it is saying that, well, let's change the amount of money transferred from this account to another account instead. We have impossible, endless trust loops, sort of things that trust something else, that trust something else, that trust something else, and that trusts the first thing. And that makes things really interesting when it comes to how they calculate the outcome of these programs. Another thing is that a lot of these programs rely on external information sources, oracles. But the problem is that not all oracles are sort of valid. And in some cases, we have found programs that sort of set up their own oracles, and the sort of results from those are quite interesting sometimes when people start to tune them to game the system, which is also something that's interesting. So one of the things that, coming back to the slide about who can you trust, well, you really need to go through these sites if you're going to use them and look at if they are as transparent as you should want them to be. When it comes to programming, well, a lot of these programs are being done extremely quickly or by people that are extremely cheap or that are, well, call them divas sometimes, and they want to show off. And the problem is that they create extremely complex programming situations. For example, we had a situation where we had 4 different layers of macros. The code was really, really simple, but when you sort of dig into the macros, there was millions of errors. But it looked good. Yeah, and then we have the open source issue. Well, it's just for it to be open source and it's transparent but not secure. I think we all know that. So we have seen teams that have been inspired by the same code base, inspired in sort of copied the code, And when a review suddenly says to one of the projects that, well, this is actually a serious bug in your system, suddenly another project that has been sort of using the same code has been attacked. So it's really like being working in the Wild West. It's fantastic to see all these different teams sort of competing against each other, and sometimes not using, shall we say, playing fair. Oops. All right, stepped on something here. Oh well. Oh. There we are. Yeah, another thing is error handling by crashing. People think that there's a really good idea to just panic the program and let it crash because the blockchain will clean it up. It does, but it leaves interesting traces on the environment where the program has been running, like private keys and other interesting things for forensics to find. And we actually found some interesting scams where the SolarWinds discussions were quite interesting to listen to, because if you have, in this case, it was 9 different sort of things that needed to be positive, that would trigger something in the program to allow the one who owned the program to sort of get rid of or get all the money in the pool. So it was quite interesting. And to sort of summarize, about $2 billion has been stolen the last 7 years. Some has been returned, but most of them has been sort of missing. And to be honest, none of these projects were actually not thoroughly reviewed. They spot-checked stuff in them. And that may be good, but if you're depending on a lot of different things, if one of those things are broken, the whole thing falls apart. And so we usually say this is a perfect storm with no reviews. You have a sort of ridiculous time to market, and there's too much money pushing for these projects to go online. So a lot of the times when we step in to do review, the program is already online on the mainnet with a huge number of money in it, and they sort of call us and say, well, there was something happening last Saturday that we were sort of thinking about. Could you please have a review of our code before we get sort of completely robbed? And sometimes we have the time, sometimes we don't. Well, I spend more or less my life on this, so if you want to spend some time with me talking about it, because I have lots more talking about it, we have a little booth around the corner. And, well, thanks.